Algebra, Lesson 6-3, Solving Systems Using Elimination. Today our goal is to create and solve systems of equations by elimination. So here's our method. We want to, number one, create equal and opposite coefficients for one set of the variables. So either for the x's or for the y's. So if I look at my x's, my values are 3x and negative 3x. The coefficients for my y's are 2 and 4. So we're looking for equal and opposite coefficients. So I believe we already have that in the 3x and the negative 3x. So then we can move to step 2. Add the equations together to create a one-variable equation. So I'm just going to turn that into an add. 3 and negative 3 make 0. 2y and 4y make 6y. And 7 and 5 make 12. Solve. Y is equal to 2. Again, our answers are ordered pairs when we're solving a system, so I have half of my answer. So we need to plug that in either to the top equation or the bottom equation, and this is where you have some choice. I'll plug it into the top equation just because the 3 and the 2 are a little smaller than the negative 3 and the 4 coefficients, and then I don't have to deal with a negative. So my top equation turns into 3x plus 2 times the 2 that we just figured out is equal to 7. Simplify. Subtract 4. And we get 3x equals 3, so x is 1. This is how you complete a systems equation by solving with elimination. Let's try some more. Solve a system using elimination or linear combination. Sometimes in a textbook or a worksheet, they will use the words linear combination and elimination interchangeably. They mean the same thing. So again, we want to eliminate either the x's or the y's. So we're looking for opposites. 4 and 3 are not opposites. Negative 2 and 2 are opposites. So these already have opposites, so we can combine them together. 4 plus 3 is 7. 2 and negative 2 cancel or eliminate for 14. Divide by 7, and the first half of our answer is 2. So I like the bottom equation better because there's no subtraction, so that's where I'm going to plug this in. So I'm taking this 2 and I'm going to plug it in for that x. So I get 3 times 2 plus 2y equals 12. Three times 2 is 6. Subtract the 6. And that y value is equal to 3. Let's get a step harder. So notice in question number 2, we have opposites already, a 2 and a negative 2. In number 3, I don't have opposites, so we have to think, where would it be easier for me to get opposites? 2 and negative 4. We're looking for our LCM, our least common multiple. So multiples of 2 are 2, 4, 6, 8. Multiples of 4 are 4, 8, 12. So we want to find a common one. So I believe 4 is our common. So if I multiply the top by 4, or by 2, I would have 4 and negative 4. To get an LCM in our y's, we would have to multiply the top equation by 5 and the bottom equation by 3, and then our LCM would be negative 15 and positive 15. But that would take more effort. So what we're going to do is multiply this top equation by 2. So our first term changes to 4x. The second term changes to negative 6y equals 8. So this top equation has now been doubled on each of the terms. And now we have opposites in our x x's, so when we add them, they will eliminate. Negative 4 and 4 eliminate. 5 minus 6 is negative 1y, and negative 8 and 8 make 0. Divide by negative 1, and y is equal to 0. We're halfway there. So I have 3 equations that I could plug into. The first and the last one are pretty much the same. The last one just has higher coefficients. So I'm going to stick to the top equation. And I'm going to plug in 0 wherever I see a y. So it's going to go right in here. So I have 2x minus 3 times 0 is equal to 4. Negative 3 times 0 is 0. Divide by 2, and I get 2. Let's practice some more like that. Solve the system using elimination or linear combinations. Again, we're looking for opposites. So I see 6 and negative 3, and a 2 and a 3. If I found opposites in the x's, I'm looking for the least common multiple, so I think that would be 6 and negative 6. So I would just have to multiply the bottom equation by 2. If I did the y's, I think my LCM is again going to be 6. I'd have to multiply the bottom equation by 2 and the top equation by 3. Which color is less work? You're right, the blue, because I only have to multiply one equation. So I'm going to try to eliminate my x's. So I'm going to multiply every term in the bottom equation by 2. Negative 6x plus 6y equals negative 18. Once I see I have opposites, I can add my 2 equations together. 6 and negative 6 eliminate. 2 plus 6 is 8y. 2 and negative 18 make negative 16. So y is equal to negative 2. Now I need to decide where is it easiest to plug in. Well, I like this first equation just because it's a positive 6, positive 2, positive 2. So I'm going to plug in negative 2 right here. 6x plus 2 times negative 2 equals 2. So a negative 4. So we add 4 to both sides, and we get 1. Let's try another one. If we were looking for opposites in the x, 3 and 2's least common multiple would be 6. So we'd multiply the top by 2, the bottom by 3. If we tried to find opposites in the y, I think we'd be looking at 20. So 4 times 5 is 20, and 5 times 4 is 20. The other thing you want to consider is that you want one to be positive and one to be negative. In the purple, I have a positive 4 and a negative 5, so those two would take care of each other. But in the red, I would have to make one of these negative. I usually like to have the bottom equation negative, so then it looks like subtraction. So either way, purple or red, they're going to be just as easy. So I'm going to go with purple because the signs are already positive and negative. So I'm going to multiply the top equation by 5 and the bottom equation by 4. So my new top equation becomes 15x plus 20y equals 30. The purple equation becomes 8x minus 20y equals negative 76. So now that we have opposites in our y's, we can add them together so that the y's eliminate. So we get 23x equals 46. So x is equal to 2. And if I double check, this was a negative 76, so that's a negative 46 for a negative 2. I hope someone caught that. So now I need to plug in. Well, these bottom two equations, number 3 and number 4, have way too big a coefficients. I don't want to deal with those, so I'm going to go with my top red equation. And I'm going to plug in right here. So I have 3 times negative 2 plus 4y equals 6. So that's a negative 6. Add it to get 12. So y is 3. Number 6. What happens when the variables don't line up? Well, these two don't match, so I want to write them both in standard form. So I want to move the 3x to the other side and the 2y to the other side. So my top equation becomes negative 3x plus 2y equals negative 4. And then the other equation becomes 5x minus 2y equals 7. And now my system lines up. Let's look at some special systems. Again, we're trying to find opposites, so the LCM of the x would be 2 and negative 2. The LCM of the y would be 6. So it looks like I want to multiply the bottom equation by negative 2. I have opposites, so now I can add. 2 and negative 2 eliminate. 6 and negative 6 eliminate, so I get 0. On the right side, 18 minus 18 is also 0. So then we ask ourselves, is this true or false? It is true, so fancy R, where all real numbers are a solution. Number 8. Our LCM for the x's would be 8 and negative 8. Our LCM for the y's would be 6 and negative 6. So I believe multiplying the top equation by 2 would help us. I get 8x minus 6y equals 40. Once I have opposites, then I can add. So I'm looking at this equation and the purple equation. Negative 8 and 8 eliminate. 6 and negative 6 eliminate, so I'm left with 0 on the left and 44 on the right. That is false. If you get something that is false, there is no solution. Those two lines would never intersect. So when you're looking at a system of equations, remember, you can get two lines that are on top of each other where every number would be a solution on those lines, or a scenario where they would never touch, so the lines would be parallel. Let's apply this. For the fundraiser, Will sold 225 candy bars. He earns $1 for each almond bar he sells and 75 cents for each caramel bar he sells. He earned a total of $187.50. We need to write a system of equations. The first equation we're going to write is going to revolve around cost. The second equation is going to be about the total number of bars we sell. So let's let x equal the number of almond bars and y be the number of caramel bars. So our equation is $1 times x plus 75 cents times y equals $187.50. The total number of candy bars sold is going to be 225. So that's x plus y has to be 225. An interesting fact with this question is that some people don't like to have systems with decimals in them. So we can modify them to get rid of them. So this is in terms of cents. So if I multiply these numbers by 100, I can turn that 75 cents into 75, the 1 into 100, and the 187.50 into 18,750. Then to get opposites in the bottom equation, I could multiply by negative 100, and then I could add my equations together. We'll finish this one later in class. This concludes my lessons on solving systems using elimination.